So hello everybody, today we're going to be doing a nice differential equation. So x is equal to y minus the sine of y prime over 2y prime. So the first thing that we're going to do is rewrite this in a slightly different fashion. So we're going to multiply everything by 2y prime. So x times 2y prime is equal to y minus the sine of y prime. Okay, or in other words, y is equal to x times 2y prime plus sine of y prime. Now we can see that this is some function of y prime. We're going to call it f of y prime. And this is some other function of y prime. We're going to call it g of y prime. Whenever we've got a differential equation such that y is equal to x times some function of y prime plus some other function of y prime, we call such differential equations as Lagrange's or Lagrangian differential equations. Okay, now how do we go about solving such types of equations? We always make a substitution. Y prime is equal to p. So that allows us to rewrite our equation as x times 2p plus sine of p. And now we can just go ahead and differentiate both sides. So y prime, and of course p is also a function of x, it's not a constant. So y prime is equal to, here we're going to use the chain rule, 2p plus x times plus 2x p prime plus cosine of p times p prime. Now remember that we said that y prime is equal to p, so instead of y prime here, I'm just going to rewrite it as p. So what we've got now is that minus p is equal to 2x p prime plus cosine of p times p prime. Or in other words, minus p is equal to p prime times 2x plus cosine p. Okay? Or in other words, we can rewrite this equation as minus p is equal to dp over dx times 2x plus cosine p. Or from here it would follow that dp over dx is equal to minus p over 2x plus cosine p. Okay? So this isn't a very nice form of an equation if we look at p as a function of x, but what we can do is perform the old switcheroo and look at x as the function of p. Or in other words, dx over dp is equal to 2x plus cosine p over negative p, which is the same as negative 2 over p times x minus cosine of p over p. Okay? Now, we can rewrite dx over dp as x prime, and we'll put this to the other side, plus 2 over p times x is equal to minus cosine of p over p. Okay, now this should probably be familiar to you by now. What do we have here? So here we have a non-homogeneous linear equation in terms of the unknown function x. So the unknown function x is actually a function of p. So as I showed earlier, the first thing that we do when solving non-homogeneous linear differential equations, we have to solve their homogeneous versions. So whatever is on the right hand side, we'll just say it's 0. So dx over, and then we'll get a separable differential equation. So dx over dp is equal to minus 2x over p, or in other words, dx over x is equal to minus 2 times dp over p. And now we can just go ahead and integrate both sides. And then we're going to get that ln of x is equal to minus 2 ln of p plus ln of c, or ln of x is equal to ln of c over p squared. So in other words, x is equal to c over p squared. Now, the method that I'm showing right now is called the variation of constants. It was developed by Lagrange as well. And what we do here is that we actually consider this c to be not a constant, but a function of our independent variable, which in this case is p. So we're going to differentiate both sides with respect to p, and then we'll get that x prime is equal to, and we're going to have to use the quotient rule, p to the 4th power, c prime times p squared minus c times minus 2pc. pc, funny, haha. Okay, so c prime p squared minus 2p times c. Okay, and everything over p to the 4th power. And we can of course simplify this a bit by canceling out some p's. So c prime p minus 2c over p to the 3rd power is the same as x prime. Okay, now let's go ahead into this equation here again, and we're going to rewrite it. So x prime plus 2 over p times x, or in other words, c prime p minus 2c over p to the third power plus 2 over p times x, which is c over p squared, is equal to negative cosine of p over p. Okay, so I'm just going to go ahead and rewrite this in another form. So c prime over p squared minus 2c over p to the third power plus 2c over p to the third power is equal to negative cosine of p over p. So these two very nicely cancel out. And here we've got, and we can, of course, multiply everything by p squared. And then we'll get that c prime is equal to negative pi times cosine, negative p times cosine p. Or in other words, since c prime can be rewritten as dc over dp, and then we can multiply everything by dp, we'll get that dc is equal to minus p cosine p dp. And now we can simply integrate both sides. So c is going to be equal to the negative integral of minus p times cosine p dp. And of course we can just solve this by using integration by parts. So u is equal to p, du is equal to dp, dv is equal to cosine p dp, and v is equal to sine p. Okay, so now we're going to get minus uv, but we have this minus here. That will be minus p times sine p minus, in the formula minus here, so that's going to be a plus the integral of sine p dp. So, which is the same as minus p times sine p minus cosine p plus some other constant, and it's a real constant this time. We're going to go ahead and call it k. So c, which is the same as c of p, is equal to minus p times sine of p minus cosine of p plus k. Now this is very important. Why? Because now we've got our x as a function of p. And we have to remember that x is simply equal to c over p squared. So when we divide everything by p squared, we'll get that x is equal to minus sine of p over p minus cosine of p over p squared plus k over p squared. Now this is the first part of our solution. We still have to get the y. Okay. And how do we go about getting y? Well, here we're going to look at this part of our equation, and we're going to get y from this, right? This formula right here. So y is equal to x times 2p plus sine p. Okay? So y is equal to x times 2p plus sine p. Okay? So when we plug in x here, we're going to get that y is equal minus sine p over p times 2p. That's going to be minus 2 sine p minus minus 2 cosine p over p minus 2 cosine p over p, okay, times minus 2 cosine p over p plus 2k over p plus sine p, and we'll just go ahead and rewrite this in a slightly better form. So minus 2 sine p plus sine p, that's just going to be minus sine p. So this here that I'm going to show, that I'm going to encompass in red, is our final solution to our problem. Okay, so this is the solution of a Lagrangian differential equation. Namely, we always have to get x and y as some functions of the parameter p and the constant k. So I hope you enjoyed this video. If so, leave a thumbs up button and subscribe. I'll see you in the next one.